Alright, tonight we're going to do another probability problem, but this time this is with non-mutually exclusive events. If you watched the previous video on the one about mutually exclusive events, this one is kind of an expanded version of that. In this one, not only do we have Republicans, Democrats, and Independents, but we have them divided up by male and female too. So we have 7 male Republicans, 8 female Republicans, 6 male Democrats, and you see so on and so forth. When you have this type of data, these are not mutually exclusive events. What we're looking for is the probability of finding a Democrat or a female. They're not mutually exclusive because they both can occur at the same time. A person can be both female and Democrat at the same time. So these are non-mutually exclusive. We set it up in this kind of chart because it's easier to work with, because you're going to need to get some totals here. You're better off going ahead and doing that to begin with. We'll add over the male line here. What's 7, 6, and 1? That's 14. And 8, 10, and 4, that's 22. And let's see. I gotta oops. I knew those numbers didn't look right. This is a 3 and this is a 1. So this is 7, 6, and 3. This is 16. And this one is 8, 10, and 1. So this one is 19. And that gives us, what, 35 total? I like to make it come out as a multiple of 5, at least for these examples, because then it reduces easily. This is 4, 6, and 10, 16, 7, and 8, 15, and I think we've added everything. Okay, now what's the formula for non-mutually exclusive events? It's going to be the probability of A or B, where A and B are not mutually exclusive. It's the probability of A plus the probability of B minus the probability of both A and B happening. And we'll talk about why that's the case. It'll make sense to you in the end. So consider this problem, the probability of a Democrat or a female. First we need, this is probability of Democrat or female. First we need the probability of being a Democrat. And that is what? 16 people, total sample space is 35, so 16 over 35 for that one. Plus the probability of B, which in this problem is the probability of being a female. Where's our female row here? Females, 19 female. Minus the probability of both A and B. Okay. Now, both A and B, that's both Democrat and female. Where would we find that on this grid? Both Democrat and female. Well, here's the female row and the Democrat column. So there are 10 female Democrats. Now, why did we subtract that? That is because these 10 female Democrats are included here when we looked at the probability of being a Democrat, and they're included again here, the probability of being female. So they've been counted twice. So we subtract them back out once. So this time we get, let's see, the common denominator, of course, is 35. That's nice. 16 plus 19 is 35 minus 10, 25. And that reduces to 5 over 7. So the probability of being a Democrat or a female is the probability of being a Democrat plus the probability of being a female minus the probability of being a female Democrat equal to 25 over 35 or 5/7.